Start.
Blessings of grace and peace be with you today and every day. Good morning to everyone. Ignite is a student mentorship program conceived and presented by the 1992 batch of engineering and technology alumni presenter across the globe. Through this event, alumni from across the globe are interacting with the students through online video conferencing and guide the students on the various career options available and how to prepare for them. These interactions are also webcast live on the Anomaly University Alumni Association's YouTube channel and will be available as a ready corner for the future generations. Ignite consists of 20 unique sections on various aspects of career building and conducted between 1st of February and 26th of February. We are in the third week of Ignite and today is the 11th section. This is going to be addressed by 3 alumni. Mr. S. Sivakumar from AMD, India R. Venkat from Intel Corporation, USA and V. Raghavan from Global Foundries, USA. Mr. R. Venkat is an alumnus of 1992 batch of Electrical and Electronics Engineering. He joined Intel Corporation after obtaining his MS in from Texas A&M University in 1995, specializing in VLSI design. Over the years, Venkat has worked on circuit, logic design, architecture, and design automation domains for several network processors, server, and client CPU designs. We now request Mr. Venkat to guide us on career opportunities in semiconductor industries.
All right. Can you all hear me okay?
Yeah, Venkat.
Okay, good. Okay, so let me kind of give you an introduction of what the industry is about. So let me just try to keep it like, nice and simple, right? So imagine science fiction movie that was made in the 90s, okay? And somebody gets up in the morning, the alarm goes off, and then there's like a digital assistant telling like, hey, here is your schedule for the day. And then like, it will dictate. What is that like you're supposed to be doing for the day? And then it quickly like, it kind of goes through your health parameters, BP, sugar, and like, other vitals, how you slept and so on. And then the coffee maker like, turns on, makes fresh cup of coffee for you. And your workday starts. You just like, turn on your computer and do your meetings, video calls, work, share data, do your personal things like banking online, transfer funds, make some like stock trades, and then like you suddenly realized, oh, I have to pay some bills. You do all of that, and you have video conference with your friends on the side, say wish happy birthday to your parents, friends, and in the evening you feel like meeting your friends, make a reservation in a restaurant online and call for a taxi. It comes there to pick you up and the reservation is waiting for you and you pay everything. And then like you already ordered like, everything that you want online. This is like, 25 years back in a science fiction movie. If I were to say that, none of you would believe it because that is the reality today. What makes all of this possible? What is the magic? Simple as the chips, the semiconductor. That is the industry that is making all of this possible. And today we are here to talk about that. Okay. And how in the history of the mankind in the last 30 years, semiconductor has completely transformed. We do every single thing from your phone, entertainment, everything is possible, streaming, playing video games. Everything is magically happening through the clouds because of this computing. Servers in the cloud, clients in your laptop, and then other chips in your smartphone. They are more powerful than whatever we can think of 50 years back. And so what is this chip design? How do we make this happen? So there are different areas within the chip design. We start from logic design or circuit design. And then we take that is coded in software, equivalent to a software, say Verilog. We call this RTL, right? Register transistor level programming, like programming in your C language and so on. And we synthesize that into a gate level netlist that gets transferred into patterns for manufacturing, high volume manufacturing. We are talking about tens of millions per day in fully automated assembly line that my friends here will talk about shortly. And this is what is doing the magic. And how can any of us get into play a role in this industry, right? So you all have an engineering background. One thing I will say is we need a graduate level degree for most of the jobs. I wouldn't say all the jobs, but most of the jobs into semiconductor because of the area of specialization. The undergrad level is too broad, and you need to do first step is to do the master's program, where you choose either the logic design or validation, or there is packaging. There are so many different areas that you can system level testing and so on and so forth. You can focus, and that would be your first step towards doing. Along the way, you could sign up for some internship in the chip design. There are a lot of chip design companies even today in India. Not only that, but anywhere from small level companies, just doing a particular IP, that is an opportunity, to big corporations like AMD and Intel and Qualcomm and so on and so forth. And what is, how did I get here? So I did my triple E or double E undergrad, passed out in '92 from Annamalai University, and did my master's in computer engineering, specializing in VLSI, basically IC chip design, in Texas A&M University. And then I joined as an intern. And like any good intern, I did okay. And then I got hired, and I've been with the company since then for the last almost 25 years. Along the way, it was a fun ride. That's all I can say. And the other thing people will be thinking, right? Like somebody coming in new, hey, what are my long-term growth opportunity? Is this industry going to sustain? And what are my potential? My only input in that regard would be, this is going to be a little bit more generic. The reality is we are in a technology sector where things evolve, if not on a daily basis, at least on a quarterly basis. Okay, so we have to keep up with the technology. So for you to get better, you need to have both depth. What I mean by depth is knowing what you're doing, circuit design, just get better at it. Ask questions, understand, try to understand the details. And then the breadth. So circuit becomes gates. Gates become something bigger. You could be spending 20 years just doing memory designs. I'm not even talking about DRAM yet. SRAM, SRAM, dual port, dual voltage rails, better power, better performance. So there are so many other aspects of it, and it keeps evolving more and more. and the project node, the process node changes, and then like you need to redo everything and make things better. Have it like, self-repair capability, okay, and repair and also redundancy to improve the yield and so on and so forth. So we have to continuously keep learning and get better at the adjacent domains and stay curious. So that is the way to like, be successful in the technology domain. And my mantra is this, okay, the day I stop learning, I start dying, okay. So be curious, keep learning. And then whatever you want to learn and then get better at, okay. There's a saying in Tamil, right? Ondre sei, adai, indre sei, adayum, nandre sei. So do one thing for non-Tamil speakers, do one thing, do very, very well and start doing it today, right? So that's one thing. And so one other thing that's along the way here is like, when we just do lot of information overload, everybody is, the key thing that everybody talks about today for people to be productive and better at whatever they are doing is stress management, okay? And you will be really surprised, and this is imbibed in our culture, and everybody is like trying to package this in different ways and forms. And meditation is now taught at the corporate level, and we get paid to do that, okay? And this is something there are different forms. There is like, of this thing available. It makes you productive. You have the opportunity, just learn and embed it in as part of your day, and you will be very productive, okay? And the other thing is, we see, this is more like a practical thing that I see. I see like, we all know, we have a lot of female people, like members of our community, engineers, I'm talking about our community, entering the workforce. However, I don't see that like, sharing of their like, household chores happening equally at home. So my request to like, all the male here, even though this is like, supposed to be career thing, for your sisters, wives, spouses, and like others to be like, equally successful, share the load with them and help them out in whichever way possible at home, because we share the house, okay? So we have equal load there as well. And what do you see as success in the long term, right? Like, success is like very, very subjective. People like, will say like, hey, making more money, better car, house, title, owning a business, a whole bunch of things. And that's what, if you let the society define success for you, that's what it's going to be. But don't let that happen. You define what is success to you, okay? If you try to put any of these things like, as success, it is going to be a moving target. What if you suddenly like, hit a lottery, or your company goes IPO, and then you made that money? Are you going to stop working? That's not going to happen, right? So have like, better thing. For example, I'll give you, say, I want to be independent in 3 to 5 years. What do you mean by that? I don't want my parents to support. I want to be able to like, support myself. And then in another 10 years, maybe do something meaningful, like, for my family. Like, maybe you may want to like, buy a house for your parents, or like, something else, or you want to master a skill. As long as you identify a skill and then you want to get better at it, have that as the measuring goal, and all other things will fall into place. We live in a age of knowledge. The more knowledge you have, you are going to be successful. And in another like 20 years, 25 years, like, make an impact to the community. Okay. So look at like, the university, right? The Annamalai University, Annamalai Chettiar made that university to give like a very affordable, like, reasonable education for literally millions of people, including me, who got like, benefited with that. So when you set your goals that way, all other things, you are going to be successful. Okay. And as far as like, if you just to use as an example, my success, what I measure myself like now to be, I joined this industry and I took this career simply to innovate and then like solve problems. So it's been a blast, like along the way. I was fortunate. The innovation in the last 20, 30 years in the semiconductor industry was tremendous. And as I said, like, in the introduction, what used to be a fantasy in a science fiction, we pretty much realized, like, most of it. And just think about the next 20 years for you all to come in and then like, use that as the baseline. And then you guys are going to be on a log scale here. Okay. What we have set as like, foundation. Okay. So I'm really excited for the young engineers who are entering this domain in starting from now for the next 5 years. It is going to be a blast. And just to conclude my thought here, okay, at the end of the day, no matter what we do and what we learn, and remember where you or we come from, and the people are the one, like, most important, and the people who helped you, family, friends, like, someone else, like, maybe the company that your dad works for or parents work for, okay, who helped you to get you where you are. And finally, to conclude this, I want to leave you with like, two quotes from one from Andy Bryant, like, our chairman. At the end of the day, semiconductor is made from silicon. We all know about it, right? So as a company, we start with just sand. Everything else is the value added by the people of the company. That is a very profound statement, okay? And one other statement quote from like, the founder of Intel, one of the founders of Intel, which is, go do something wonderful. I'm pretty sure you're all going to do something very wonderful. Thank you.
Thank you for your inspiring speech, sir. Next, we invite Mr. S. Sivakumar is from the batch of 1992, Electronics and Instrumentation Engineering. He is manageability domain expert. His career mainly has been with Intel and AMD, exploring very sharp inner skill set. Presently, he is working as a fellowship at AMD and is serving as a vice chair of CIM firm and DMTF industry body, which creates open manageability standards. Over the years, Shiva has been instrumental in building manageability domain related specifications, microcontrollers, firmware, and software products from client computers, enterprise servers, telecom servers, data center, and HPC segments. We welcome Mr. Sivakumar sir to share his views.
Hi, am I audible?
Yes, Shiva.
Yes, sir.
Thanks, Bhuvneshwari, for the intro there, and thanks for the organizing committee here of Ignite, specifically Mahendra Kumar and team, and thanks for the opportunity for me to talk in this forum. I literally watched all the talks so far, and really they have been motivating to me itself. So I encourage everyone, if you have not watched all of them, go back and listen to them. I learned a lot from my colleagues, from my same batchmates, and really feel fortunate that I was part of a batch that has been doing successful in all areas. There are only few that might be talking to you during this course of event, but I'm pretty sure there are other accomplished people as well from this batch who are not talking to you. But Annamalai University has been great in producing talent, and some of them are sharing this, and hopefully you'll make use of it. So kindly go watch all of the talk that has been done. It's for your benefit. I specifically, the speech from Chokkalingam, I liked it very much. I follow him, but I really want to follow some of the other aspects that he brought about related to punctuality, related to memory, all those aspects, right? So anyway, coming back to the agenda, what I want to speak about is my career journey. I will just quickly touch upon it and give a glimpse about the semiconductor industry. Venkat has pitched a very good intro of how in a day-to-day life you are being affected by, today you are affected by semiconductors, and which is going to be even more prevalent as day goes on, right? So, and specifically, I'll then come back to the software areas, right? In the semiconductor industry, in the software area, what is the opportunities and what is the impact that you can create as a software engineer in the semiconductor industry. So that's what I would like to do. Let's start with the career journey of myself. Obviously, 1992, I graduated from Annamalai University. I was an above average student. I scored around 74% in electronics and instrumentation, with my favorite subjects being microprocessors, process control, and hating digital signal processing, as many of them do. DSP was a nightmare to me. Obviously, I loved engineering, drawing, and maths. I scored centum on both of these subjects. I cherish those moments in Annamalai University. And obviously, I was active in Navy, going to Pichavaram and it instilled a lot of discipline in me, being part of the Navy thing. And I was also participating in a lot of curricular activities like volleyball team of engineering and technology team. So, and I was the class rep when in the final year when I came out of Annamalai University in the electronics and instrumentation branch. That was brief how I came out of Annamalai University. It really instilled a lot. That was the first time I came out of my family and lived alone. So it just really gave me an opportunity to face life, right? Just face the society, right? From there on, it was a shock to me. I was left into the job market. I had a little bit of challenge for my first job. Getting my first job, it was difficult. I would say around 9 months, I struggled with my neighbors, with my relatives, everyone asking what's going on. You have finished your engineering, you don't have a job in your hand. I can relate to the same circumstances now you guys are. I have a son who's in the final year of engineering, and my daughter who has completed engineering, and she's working right now as a software engineer. And my son is in the final year and has got recruited in Mercedes-Benz, right? So though I had a struggle, fortunately, they immediately got in campuses, both of them. So I do remember those days where I'd taken at least 90 to 100 interviews in those 9 months. And then I went to Bombay, since there were not much opportunities in Tamil Nadu for electronics and instrumentation. I went to Bombay to see if I can land up in a job related to my industry, right? Since I was not getting an opportunity, I turned my focus towards software. Right, so I did some couple of courses in software, and I got recruited in a startup. Which was a blend of both electronics and software. So it was a very new company. They were trying to build PLCs, programmable logic controllers. It's now right now the company is called as Sharpline Automation, which is doing good. It was a startup at that point of time. I started by writing softwares to these programmable logic controllers. I wrote the compilers for this. on my own. That was my first job. It gave a lot of confidence to me that I can achieve something, because it was a very small company. There are not much people. Throughout my career, it has been like that. I was never trained for something. It was something always, if it is a challenging environment I get, I will be the first person to do that. I just take it up and do it. That is something that I would tell, like, some things come through training, something is your own motivation to take risks in the innovation front. So that is a problem statement. How do you innovate to solve that problem, right? So that is very critical. That has been there throughout my career, starting from my first job, which gave me the full satisfaction and confidence that I can build a successful career on software itself, right? So that was my first job. From there, I moved on to Chenab Information Systems, through which I worked in Swissair. That was also a financial software kind of company. Briefly, I worked there for 1 year in Switzerland. And then I returned back and moved to US and started working for Intel in 1996 timeframe. That was when I initially started a domain knowledge. Like, so still till that time, it was just purely programming languages. I knew programming languages. I knew some background about electronics. That's it. But then, how do I focus my career on which particular domain? Not just calling it literally software. All layers of software are important, right from the firmware to the host applications, right? But how do I specifically focus on a particular domain? That was the opportunity I got in Intel immediately. So manageability was one aspect that I felt that I can grow my career, because that was, as Venkat was alluding, right? Semiconductor was growing during this period, like the servers, client systems, all were coming into the market. These have to be managed properly, right? That too in an enterprise or a telecom environment. These systems have to be managed properly, right? So, so when you create a SOC, was certain capabilities so that it can be managed. So that is the perspective in which I developed my domain knowledge. From Intel, from 1996 to 2009, I was with Intel. I've been throughout working on manageability domain. So in between, just wanted to bring out one point there. Around 2004 or 2005, I had a personal reason that I had to come back to India. That is why I want to bring in what Venkat talked about, work-life balance as well, which is very important. Career is one important aspect, but at the same time, family and health, all are critical, right? So I made a conscious decision. I was in the peak of my career, representing Intel in industry forums, having all the opportunities to grow further in US. But because of family reasons, I had to come back. But though I come back, I never regret it, because I have created the opportunity here in India to be as successful as I would have been in US, right? So I just want to hit upon that point that it doesn't matter where you are, and that too with this present situation of you can work from anywhere, because today everyone are working from home, right? And still you can be as successful in anywhere, any part of the world. I just want to make sure that I convey that. So after Intel, I joined AMD in 2012, and I've been with AMD since then, and still working in the manageability domain, writing specifications and building products, software products related to that, right? So this is just a brief journey of me, starting from a pure software person to a domain knowledge in manageability in Intel and AMD. But let me quickly bring up a couple of slides to just share. Is the slides visible?
Yeah, Shiva.
Okay. So basically, this is just a brief view of the couple of companies in the semiconductor industry. It's not the holistic set of companies, but just to give an idea. And normally, right, as Venkat was talking about, these companies design start from silicon, the sand, right? Design some put some circuits together and design an RTL and try to complete the design and hand it over to manufacturing. Like my co-batchmate Raghavan will talk about the manufacturing environment. Like these companies are involved in manufacturing the silicon. So a design of the silicon is done by these companies, and then manufacturing is done by these companies. Then there is a reiteration between these companies, like, okay, whether all the manufacturing elements are properly developed, so that after that post-silicon verification is done, it goes to companies like this to build products, right? To build the end products that you will be utilizing at the end of the day, that we are utilizing today, right? So this is the gist of the semiconductor industry, like where we come from. Venkat comes from Intel, I come from AMD, where we create these designs and hand it over to the manufacturing companies like Global Foundries, like Raghavan will talk about. And then it goes to system builders to build the final products, which will be ending up with the end users, right? So this is just a glimpse of it. Now I just want to touch upon briefly on software, right? What is software, typical software and firmware areas in the semiconductor industry, right? Right from the pre-silicon verification that Venkat talked about, before even the SoC is being manufactured, like there are emulators and simulator models on which software can be developed, right? I'm not talking about the RTL design C programming that Venkat talked about. I'm talking about you need some firmwares and applications to run on the SoC finally that is being designed and developed, right? So before even the SoC is being manufactured by the manufacturers like Global Foundries or TSMC, like the semiconductor companies who are the software teams run their software on the emulators and simulator models, so that when the it gives them a lot of head start when the SoC gets manufactured and comes into the premises again. So once this is there, the SoC comes back from the manufacturers, like there is a post-silicon validation that happens. And then slowly we start bringing up the firmware elements. There are a lot of microcontrollers within the SoC, right? Which is a GPU, CPU, it can be a APU. There are a lot of small microcontrollers that sit within this ACU, within this SoC. So we have to write firmwares for all these management controllers. All these firmwares have to be brought up. And there are a lot of debug tools that are created to debug this SoC, like at a register level, right? So these are all software, firmwares and softwares that are built in the semiconductor industry, like. And then though there are separate IBVs, like individual BIOS vendors, there are separate companies who build BIOSes. But from a SoC point of view, like we have to make sure that the platform generic BIOS is exposed to these IBVs to integrate and work on these SoCs. So there is a BIOS angle to it, like where we need people around BIOS segment as well in the semiconductor industry. Then in the OS level also, we need certain drivers that are very much tied to the SoC elements. So we need people to create drivers or develop drivers. And obviously, why are we developing all this, right? At the end of the day, there has to be some application running about it. The performance of it is very critical. So compilers has to be optimized and performance libraries have to be created. Like, and in this industry, creating those compilers and performance libraries are also the duty of the software wing of the semiconductor industry. And once you have this application, whether it is properly can be debugged, the appropriate hooks are there to the SoC from debuggers' point of view and profilers' point of view. Are these applications tuned properly, utilizing all the resources properly? We need the debuggers and profilers around, right? Then obviously we do not ask it goes up, the association of the software is less. So tools and applications, obviously, there is a lot of ecosystem there in the industry creating applications for the SoCs that we create. But for the domain, specific domains like manageability, security, all that, we do develop tools and applications as well, so that the industry has the appropriate building blocks when they create the holistic solution based on these products. This is just to give a quick gist about the layers of softwares that can be created and contributed in the semiconductor industry. Hope this is useful, that it's not just that drivers are used in a pure software company like, or compilers or debuggers. You have to join Microsoft to write compilers. It's just there's a lot of contributions that semiconductor industry software wing can do in the software levels. That's my main intention of sharing this architecture diagram. So at the end, I just want to reiterate what Venkat said, like masters is something that we look out for, and internship is through which co-ops or internship, we call it as, is one of the major avenues through which we recruit people fresh from college. So if you are a master's graduate, we do approach a lot of colleges to come in and be part of the co-op opportunities and internship opportunities. And post that, obviously, it is also, after some experience also, you can come back. But if you have experience in compilers, drivers from other companies, certainly you can transfer to a semiconductor industry as well, right? So, and one additional point I want to reiterate is related to being in India. Or will you be able to thrive in semiconductor industry? Absolutely. Like, we do end-to-end development. Being in India, we own the course design, we own the software designs, not only validation or something like that. There might be perception, like it might have been the way that it started in past, but as of today, the reality is right from the architecture to the final implementation as a product, entirely it is done in India. A lot of aspects is done in India. So I just want to reiterate that point before I conclude. And thanks for the opportunity to the Ignite team, like Mahindra and team.
Thank you for your speech, sir. And then Mr. V. Raghavan is also from the batch of 1992, Electronics and Instrumentation Engineering. He has been in quality management for last 24 years. He is currently handling customers' quality for leading edge fabs within Global Foundries. After finishing his engineering in 1992, he was running his own business for 2 years and then did his MBA from Cyprus. After that, he joined a semiconductor startup company in Singapore. From there, he moved to US in 2013 to establish the customer quality team for the new fab. Automotive quality management system, ISO, IATF compliance, quality audits, change management are some of the expertise he adds value in the company. We now welcome him to guide us on the career opportunities in semiconductor sector.
Thank you, Paul. Thank you for the nice introduction. Is my voice audible? Can you hear me, guys?
Yeah, Raghavan.
Yeah, okay. And I would like to thank the organizers, Ignite team, Mahendra and Damodaran, and the rest of the team of Annamalai University Alumni Association for this creating this wonderful opportunity for the students, right, which we didn't have during our times. So I really hope the students take full advantage of this and then build their career aspirations and get the maximum help out of this opportunities, right? So, and without further ado, let me get into the talks, right? I continue to build on what Venkat and Shiva has shared on semiconductor careers. Are you guys able to see my screen?
Yeah.
Okay, so I purposely pulled this photo, the picture from our crescendo, which is our memorable crescendo that we published during our college days. ஸோ நாங்கள் ஃபைனல் இயர் படிக்கும்போது எங்களுடைய ஞாபகார்த்தமாக இந்த கிரெசண்டோன்னு ஒரு புக்கு நாங்கள் வெளியிட்டோம். அதில் வந்துட்டு இன்ஸ்ட்ருமெண்டேஷனுக்கு வந்து தெரிஞ்சோ தெரியாமலோ ஐசி சிப் படம் போட்டு எங்களோட ஃப்ரெண்டு கோப்ராங்கிறவர் வந்து வரைஞ்சிருந்தாரு. அப்போ ஐ நெவர் ட்ரீம்ட் தட் ஐ வில் பி ஒர்க்கிங் இன் அ கம்பெனி வேர் வி மேனுஃபேக்சர் த ஐசி சிப். Okay, so that's a reality, right? We used to have like a couple of subjects on the VLSI as part of the electronics, and we know roughly, okay, very large scale integration and the transistor and some semiconductor basic stuff. That's all we did in the engineering, right? But by God's grace, I ended up in a company, and I've been working like almost 25 years in the IC manufacturing world. Okay, so this is my kind of a snapshot of my career. As you guys introduced me, I started. I mean, engineering முடிச்சோன்னே சிவா சொன்ன மாதிரி தான், வேலையெல்லாம் ஒன்றும் கிடைக்கல பெருசா. அண்ணாமலை யூனிவர்சிட்டி முடிச்சுட்டு கேம்பஸ் அவ்வளோவா கிடையாது. And I started my own startup. It's like a marketing, right? A hardware sales company, a distributorship company, right? That's where I picked my skills of marketing, because job market, எங்க நீங்க போனாலும் you have to sell yourself. So that's where I picked up, right? அதுக்கப்புறம் வந்து அப்பவே வந்து ஒரு பார்ட் டைமா சொந்த பிஸ்னஸ் பண்ணிட்டு I joined a kind of a distributor to Godrej, where they sell electronic typewriters. That's where I got to meet the industrial clients and I got the exposure. Then I decided to do my MBA. I thought that would help me in becoming more competitive in the job market, right? So that was a struggle during 90s. I mean, it was not an easy world for us to get into a job other than the cream of the cream students. I was definitely not one of them. I was like average. So then after my MBA, Annamalai University taught us life. How to live independently, how to manage yourself independently. Annamalai University hostel life is a wonderful place where you can learn about life. And when I went to Cyprus, I got the other perspective of international exposure and living yourself and managing your finances and everything, right? So after MBA, with that confidence, I moved to Singapore and looking for a job. And finally, I ended up in a startup company as a career. I mean, I started my career, right, in the semiconductor. I didn't know that I would last for 25 years, but I took up the job because I didn't have any other option. So I started in a startup company. And then as a management trainee, I started. And then within 3 months, there was a need for a quality engineering role. So I was thrown that role. Okay, you are a management trainee and you have an MBA, and we hope you can pull this off. So my first project was to get the ISO 9001 certification compliance for that startup company. And the startup company was a supplier to one of the major companies in Singapore, Semiconductor Foundry. I mean, back then it was known as Chartered Semiconductor. Now we are called as Global Foundries. So with that network building, I moved to Chartered Semiconductor a couple of years later, started 1999. So since then, I've been with that company for almost 25 years, and now I'm in US working in the same company in the quality management field. So with that, let me get into the semiconductor market overview, right? As Venkat mentioned, semiconductor is everything, right? You might have heard the phrase called "engineers make the world," right? Engineers make the world, which is truly happening in the semiconductor. We make the world, absolutely, like what Venkat said. இப்போ நீங்க கையில வச்சிருக்க ஸ்மார்ட் போனு, இப்போ நம்ம பேசிட்டு இருக்க ஜூம் கால்ல, everything is enabled because of the semiconductors, right? So that's why I want to give you a market overview, right? It's everywhere, starting from the car, the motorbikes that you're riding, and the flights you're flying, military, mobile phones that you're having in your hand, computers, and data center and healthcare. You go to the hospital, your people are taking your blood pressure, sugar, ECG, whatever you talk, right? Semiconductor illama ipo edume kediyadu. So the opportunity is immense. That's what I wanted to tell you. Opportunity is immense, and the way if you think you want to create, make yourself a career in the semiconductor industry, start preparing for that. Build up your skills. வெறும் இன்ஜினியரிங் டிகிரி மட்டும் பத்துமான்னு கேட்டா கண்டிப்பா பத்தாதுன்னு தான் சொல்லுவேன். Maybe it will be able to help you get you an entry level kind of position, but Anna, you need to build up your skills to sustain in this, but you will really enjoy because it will be a rewarding career in the semiconductor industry for sure. Okay. Siva showed a glimpse of the companies, but this is the latest from the press, the top 15 semiconductor world leaders, right? And majority of these companies already have a big establishment in India. Bangalore, Hyderabad, Chennai. சென்னையில வந்து கொஞ்சம் கம்மியா இருக்கு. Bangalore and Hyderabadல you have all these big companies, they have a presence. And North India, of course, they have as well, right? So all the big names are there. So it's up to you to find your way and navigate yourself with every help that you can get from your professors, from the college, from the seniors, from the mentors, everybody, to navigate yourself and to get to one of these companies, right? And the competition will be tough. I can understand that, but it is not that you cannot make it, right? You can definitely make it. So manufacturing, right? I come from a manufacturing perspective. So Siva and Venkat are in the design and firmware and software perspective, but I come in the manufacturing. So where all the manufacturing exists, right? It exists everywhere, every stage of the semiconductor. If you talk about the front end, முதல்ல மணல்ல இருந்து ஆரம்பிக்கிற அந்த சிலிக்கன் நாங்க சொல்றோம்ல, சிலிக்கன் வேஃபர், சிலிக்கன் சொல்லி சிவா 2-3 தடவை சொன்னாரு. It comes from the sand, nothing else. Sand is the raw material. அங்க ஆரம்பிக்குது மேனுஃபேக்சரிங். சிலிக்கன் வேஃபர், இங்காட்னு சொல்லுவோம். சிலிக்கன் வேஃபர் மேனுஃபேக்சரிங், தட்ஸ் வேர் மேனுஃபேக்சரிங் ஸ்கில்ஸ் அங்க இருந்து ஆரம்பிக்குது. போட்டோ மாஸ்க் மேனுஃபேக்சரிங், கீழே இந்த படம் போட்டிருக்கேன் பாருங்க. ஏன்னா இது ஒரு கிளாஸ்ல டிசைன், சர்க்கியூட் டிசைனை வந்து பிரிண்ட் பண்ணி அதை போய் வேஃபர்ல பிரிண்ட் பண்றது தான் மேனுஃபேக்சரிங். இட்ஸ் ஆல் அபவுட் நட்ஷெல். ஐ மீன் சிம்பிளா சொல்லணும்னா. அதுக்கப்புறம் ஃபேப்ல தான் நான் ஒர்க் பண்றது. VLSI ஐசி மேனுஃபேக்சரிங். ஒரு 600-700 ப்ராசஸ் ஸ்டெப்ஸ் திருப்பி ரொட்டேஷன்ல வரும். And it takes about 3 months for a product to be manufactured, for a wafer to be manufactured. So that is the longest process in the manufacturing whole cycle. அதுக்கப்புறம் assembly and test. சென்னையில மறைமலை நகர்ல ஸ்பெல், எவ்வளவு பேர் கேள்விப்பட்டிருக்கீங்கன்னு தெரியல, ஸ்பெல் ஸ்பிக் எலக்ட்ரானிக்ஸ் வந்து assembly and test, OSAT சொல்லுவாங்க, semiconductor assembly and test. They have a big establishment there, and there are other OSATs as well in India. அப்புறம் finally end customers. We sell it to Qualcomm, Broadcom. அவங்க வந்து they will sell it to computer companies like HP, Lenovo. கடைசியில உங்களுக்கு வந்து end customer application வந்து என்ன, ஒரு லேப்டாப்போ, ஒரு ஐபோனோ, ஒரு ஐபேடோ, ஏதோ ஒன்று உங்க கையில வந்து இருக்குமே, அதுதான் end customer application. அதுவும் மேனுஃபேக்சரிங் தான். ஸோ நீங்க நிறைய கம்பெனி ஹைதராபாத்லாம் கேள்விப்பட்டிருப்பீங்க. ஃபாக்ஸ்கான்லாம் வந்து they just do this contract manufacturing. அவங்க பேர்ல எந்த ப்ராடக்ட்டும் கிடையாது, but they manufacture for the rest of the people. So manufacturing is a big industry. I mean, big portfolio that you can enable yourself from any engineering discipline, right? If a design software லாம் போனீங்கன்னா வந்து the skill level needed is much higher. But manufacturing la வந்து to get into an entry level, it is relatively easy. I'm not saying it's easy, but it is relatively easy. So with that, right? What are the job opportunities we call, right? Process engineering. We call process engineering, equipment engineering, manufacturing engineering, quality engineering. குவாலிட்டி டொமைன்லாம் வந்துட்டு நம்மளோட கரிக்குலம்ல வந்து அவ்வளோவா டீச் பண்ணவே மாட்டோம். குவாலிட்டி மேனேஜ்மெண்ட் சிஸ்டமோ, ஒரு குவாலிட்டி பிரின்சிபல்ஸோ, ஒரு குவாலிட்டி ஒரு இதுவோ நீங்க மாஸ்டர் டிகிரி போகும்போது ஒரு எலக்டிவா படிக்கலாமே தவிர, இன்ஜினியரிங்ல வந்து பிகாஸ் ஆஃப் த டைம் அண்ட் த அவைலபிலிட்டி ஆஃப் த courses, right? Quality engineering லாம் தனியா டீச் பண்ண முடியாது. பட் ஆனா that is the area in itself which you can build a career. And நானே அதுக்கு ஒரு எக்ஸாம்பிள். 25 years I'm managing, I mean I'm going through that quality engineering career. I never switched anywhere else. அப்புறம் customer engineering, managing customers from bridging the customer need to the manufacturing need. That's what is customer engineering. Facilities engineering, we need water. எல்லா மேனுஃபேக்சரிங் பிளான்ட்லையும் பார்த்தீங்கன்னா we call DI water, reverse osmosisல DI water, the cleanest water without all the deionized water, right? We need water, and we used all the chemicals, all ultra pure chemicals, all type of chemicals, and we need electricity management. நீங்க படிக்கிற ஜெனரேட்டர், எலக்ட்ரிக்கல் இன்ஜினியர்ஸ் யாராவது இப்போ இதுல இருக்கீங்கன்னா எனக்கு தெரியாது, நீங்க படிக்கிற ஜெனரேட்டர்ஸ் ஆகட்டும், பவர் மேனேஜ்மெண்ட் சிஸ்டம்ஸ் ஆகட்டும், everything is needed in manufacturing. So facilities engineering வந்து it's a big area in itself. அப்புறம் information technology, of course computer science and IT, right? We call computer integrated manufacturing. ஸோ அது நீங்க சாஃப்ட்வேர்ல படிக்கிற ஒரு கம்ப்யூட்டர் சயின்ஸ் படிக்கிற ஸ்டூடெண்டா இருந்தா, சாஃப்ட்வேர்ல செமிகண்டக்டர் மேனுஃபேக்சரிங்னே ஒரு ஸ்பெஷல் டொமைனே வந்து பெங்களூர்லாம் டீச் பண்றாங்கன்னு நான் கேள்விப்பட்டேன். நான் அங்க இருந்தா நாங்க ரெக்ரூட் பண்றோம். எங்களோட கம்பெனி எஸ்டாப்ளிஷ்மெண்ட்டே வந்து பெங்களூர்ல இருக்கு. குளோபல் ஃபவுண்டரிஸ் கேள்விப்பட்டிருக்கீங்க. பெங்களூர்ல இட்ஸ் a big establishment. மெயினா சாஃப்ட்வேர் பீப்புள் ஆர் கைண்ட் ஆஃப் ஹெட் குவார்ட்டர் தேர். So these are the kind of இது வந்து ஒரு சின்ன ஸ்னாப்ஷாட் தான் கொடுத்துருக்கேன். There are many other jobs that you can get into the semiconductor. So what are the sought after engineering majors, right? all the branches, whatever branches that Annamalai University is offering right now, you are eligible to get into a semiconductor industry. As I said, electronics, electrical, chemical, mechanical, production, industrial, manufacturing, IT, computer science, material science, environmental engineering, anything, all these disciplines are much needed in the semiconductor manufacturing. I mean, all manufacturing, but semiconductor manufacturing, of course, we need as well. So I just want to give a quick sneak peek into quality engineering career. நான் ஏன் முதல்ல சொன்னேன்னாக்கா, நம்ம கரிக்குலம்ல வந்து அவ்வளவா உங்களுக்கு குவாலிட்டி இன்ஜினியரிங் பத்தி ஒரு சப்ஜெக்டோ ஒரு இதுவோ இருக்காது. ஆனா நீங்க வேலைக்கு போகும்போது ஒரு மேனேஜ்மெண்ட் ட்ரெயினியா நீங்க போவீங்க, ஒரு ஃப்ரெஷ் ட்ரெயினியா, ஒரு இன்ஜினியரிங் கிராஜுவேட் ட்ரெயினின்னு சொல்லுவாங்க இந்தியாவில். அந்த மாதிரி உங்களை ரெக்ரூட் பண்ணுவாங்க. ரெக்ரூட் பண்ணிட்டு உங்களை வேற ஃபீல்டுல தே வில் கைண்ட் ஆஃப் பிளேஸ் யூ. ஓகே, நீங்க உங்களுக்கு டிசைன் ஆட்டிடியூட் இருந்தா டிசைன் போங்க, இது ஆட்டிடியூட் இருந்தா இங்க போங்க அப்படிங்கிற மாதிரி அப்படிதான் குவாலிட்டிக்குள்ள போமே தவிர. ஆனா இப்போ வந்து யூ கேன் ஐம் சீயிங் கிராஜுவேட்ஸ், நான் இங்க ரெக்ரூட் பண்ணும்போதோ இல்ல இங்க வந்து நான் மென்டர் பண்ற ஸ்டூடெண்ட்ஸ் எல்லாம் பார்க்கும்போதோ, they are doing courses on their own while they are doing their master degree or college. அதாவது இந்த ISO 9000 கோர்ஸ் இருக்கு, குவாலிட்டி டெக்னிக்ஸ், குவாலிட்டி பிரின்சிபல்ஸ் கோர்ஸ் இருக்கு. அந்த மாதிரி கோர்ஸ் எல்லாம் அவங்க வந்து எலக்டிவா பண்ணி they want to get into the quality straight away. I mean, ஒரு லீப் அஹெட் நான் சொல்லுவேன். அதை வந்து கம்பெனிக்குள்ள வந்து நீங்க கத்துக்கிறதுக்கு பதிலா நீங்க முதலே அதை படிச்சுட்டு வந்தீங்கன்னா உங்களோட சான்சஸ் ஆர் மச் ஹையர். ஸோ இஃப் எனிபடி இஸ் இன்ட்ரெஸ்டட் அண்ட் எனிபடி ஹூ ஹேஸ் அ நேச்சுரல் எபிலிட்டி ஆர் டீடைல்ஸ் டு அட்டென்ஷன், அதாவது ஒரு தப்பை வந்து பார்த்த உடனே ஒரு கண்டுபிடிக்கிறது, அந்த மாதிரி ஒரு அட்டென்ஷன், அந்த மாதிரி ஒரு ஆட்டிடியூட் இருக்க பர்சனுக்கு குவாலிட்டி இன்ஜினியரிங் இஸ் அ வெரி ஆப்ட் ஃபீல்டுன்னு நான் சொல்லுவேன். ஏன்னா என்னோட இதை நான் அப்படிதான் தெரிஞ்சுக்கிட்டேன். ஐ மீன், மேனேஜ்மெண்ட் ட்ரெயினியா உள்ள போய் the way I started working, I started finding issues and I started paying attention to details. That's when they thought you should be a better fit for quality, and why don't you take this challenge and get us the ISO. அப்படிதான் நான் உள்ள போனேன் குவாலிட்டியில. பட் this is like giving you a snapshot of what is quality, right? Everywhere ஒரு ப்ராடக்ட் நீங்க உள்ள கம்பெனிக்குள்ள கொண்டு வரணும்னா சப்ளையர் குவாலிட்டி, இன்கமிங் குவாலிட்டி, அப்புறம் மேனுஃபேக்சரிங் ப்ராசஸ் நடக்கிற இடத்துல மேனுஃபேக்சரிங் குவாலிட்டி ஒழுங்கா நடக்குதான்னு. முன்னாடி எல்லாம் குவாலிட்டினா ஒரு ஆடிட், ஒரு கண்ணு, ஒரு இன்ஸ்பெக்டர், அப்படிதான் வந்து நம்ம நினைச்சிட்டு இருப்போம். பட் ஆனா செமிகண்டக்டர்ல அப்படி கிடையாது. இட்ஸ் ஃபீல்ட் இன் இட்ஸ். நம்ம இல்லாம பண்ணவே முடியாது. குவாலிட்டி இன்ஜினியரிங் இன்வால்வ்மெண்ட் இல்லாம எதுவுமே நடக்காது. அந்த மாதிரி தான் செமிகண்டக்டர் மேனுஃபேக்சரிங், பிகாஸ் த ஸ்பெசிஃபிகேஷன் and the room for error is very little. And if you make a mistake, it is very expensive to fix it. So அதனால quality aspect வந்து it's built into the process னு சொல்லுவோம் நாங்க. So அதனால quality engineering வந்து it's a very good kind of field if you want to get into the semiconductor. And the one more beauty of being in the quality engineering, you can fit into any industry. With the quality mindset and quality management experience, you can fit into any industry, not necessarily semiconductor. Semiconductor la ipo neenga switch panni ponunaaka you will be easy, it will be easy for you to switch your career in the quality field. And நீங்க கேள்விப்பட்டிருப்பீங்க, ISO வந்து வெரி காமன் இன் இந்தியாலுமே. இப்போ வந்து ISO வந்து எல்லா கம்பெனியுமே வந்து ISO சர்டிஃபிகேஷன் வாங்குறாங்க. அதுலேயே வந்து automotive car manufacturing தனியா இருக்கிறது தான் IATF. That's what I said, ISO and IATF. These two are a big field in itself. ஏன்னா எந்த கம்பெனி மேனுஃபேக்சரிங் காருக்கு சப்ளை பண்ணாலும் IATF வேணும். அந்த IATF எவ்ரி இயர் அவங்க ஆடிட் பண்ணி சர்டிஃபிகேட்டை வந்து மெயின்டைன் பண்ணணும். ஸோ ஜாப் செக்யூரிட்டிங்கிறதும் வந்து இதுல வந்து கிட்டத்தட்ட ஒரு மாதிரி நல்லாவே இருக்கும் உங்களுக்கு குவாலிட்டி இன்ஜினியரிங். ஸோ just want to give you a sneak peek into quality engineering. I want to talk a little bit more about the career building, right? So technical skills வந்து நீங்க வந்து எல்லா எக்ஸாம் எழுதி பாஸ் பண்ணிடுவீங்க, அரியர் வைக்காம பாஸ் பண்ணுவீங்க, 70% 80% டிஸ்டிங்ஷன்லாம் மார்க் வாங்கி வந்துடுவீங்க. அது வந்து டெக்னிக்கல் ஸ்கில்ஸ். எக்ஸாம் எழுதி 5 யூனிட்ல 4.5 யூனிட் நல்லா பண்ணீங்கன்னா யூ கேன் கெட் லைக் 80 மார்க்ஸ், ரைட்? அந்த மாதிரி தான் நாங்களும் பண்ணிடுவோம். பட் ஆனா ஜாபுக்கு நீங்க போகும்போது, இன்டர்வியூ போகும்போது டெக்னிக்கல் ஸ்கில்ஸ் வந்து ஒரு 50% 60% வேல்யூ தான். அது ஃபர்ஸ்ட் உங்க ரெஸ்யூமே எடுக்கிறதுக்கு உங்க மார்க் லிஸ்ட் ஹெல்ப் பண்ணும், நான் இல்லைன்னு சொல்லல. பட் ஆனா அதுக்கப்புறம் வாட் தே லுக் இன்டு தி திங், ரைட்? The soft skills that we need in semiconductor industry, in any industry for that matter. Communication skills, how well you're able to communicate, how good is your presentation skills. ஏன்னா நாங்க படிக்கும் போதெல்லாம் வந்துட்டு எங்களுக்கு பிரசன்டேஷன் வந்து இருந்தது, பட் ஆனா ரொம்ப கம்மியா இருந்தது. I believe I'm hearing a lot of good things that is happening in Annamalai University from our friends, from my alumni friends. And so I believe you have a lot of opportunity to improve your presentation skills. And critical thinking and teamwork ஆர்கனைசிங் ஸ்கில்ஸ், ப்ராப்ளம் சால்விங், அடாப்டபிலிட்டி டு என்விரான்மெண்ட், இதெல்லாம் தான் வந்து சின்ன சின்ன சாஃப்ட் ஸ்கில்ஸ் will help you differentiate from a competitor. ஏன்னா ஒரு ஜாபுக்கு 10 பேர் நீங்க அப்ளை பண்ணீங்கன்னா அந்த 10ல எனக்கு நான் ஒருத்தர் தான் நான் வந்து கன்சிடர் பண்ண முடியும்னா அதை எப்படி நான் எடுப்பேன்னாக்க எல்லாருமே கிட்டத்தட்ட 80% மார்க் லிஸ்ட் வச்சிருப்பாங்க. அப்போ ஐ வில் ட்ரை டு லுக் ஃபார் டிஃபரன்ஷியேஷன். யாரு வந்து டிஃபரன்ஷியேட் பண்றாங்க அப்படின்னு. அது எதுல நீங்க டிஃபரன்ஷியேட் பண்ணலாம்னா the way you talk, the way you present yourself, the way you sell yourself, இதெல்லாம் தான். ஸோ இஃப் யூ pay attention to this and get yourself trained, நீங்க மென்டார் சீனியர்ஸ் நான் சொல்றதெல்லாம் இந்த மாதிரி சாஃப்ட் ஸ்கில்ஸ் அக்வயர் பண்றதுக்கு யூஸ் பண்ணுங்க. டெக்னிக்கல் ஸ்கில்ஸ் யூ கேன் கெட் ஃப்ரம் யுவர் டீச்சர்ஸ், நீங்க புக்கை படிச்சு அந்த மாதிரி வந்துக்கலாம். ஆனா சாஃப்ட் ஸ்கில்ஸ் கம்ஸ் ஃப்ரம் ஒன்லி ஃப்ரம் மென்டர்ஸ் அண்ட் எக்ஸ்பீரியன்ஸ் பீப்புள். ஸோ please pay attention to this, and especially final year students, I think this will be very, very helpful. And career planning fundamentals, what I would say, self assessment. இது வந்து நிறைய பேர் ஏற்கனவே பேசிட்டாங்க. நீங்க 20 நாள் இப்ப பேசி கேட்டுட்டு வரீங்க. ஸ்ரீனி வந்து முதல்ல பேசினாரு, அவர்லாம் வந்து அதான் சொன்னாரு. செல்ஃப் அசஸ்மெண்ட் வெரி வெரி இம்பார்ட்டன்ட். உங்களோட ஓன் வீக்னஸ் அண்ட் ஸ்ட்ரென்த் அதை தெரிஞ்சுக்கிட்டு அதை உள்ளபடியே நல்லா உண்மையா வித் இன்டெகிரிட்டி கோ அண்ட் அண்டர்ஸ்டாண்ட் யுவர் செல்ஃப் and build on your weakness. Build to improve your weakness, make it a strength. உங்களோட வீக்னஸ் உங்களுக்கு தெரிஞ்சுன்னு வச்சுங்களேன், that will be the best thing because you know how to fix it and you can only get better. So self assessment and career exploration. என்ன மாதிரி ஜாப் உங்களுக்கு பிடிக்கும், பேஷன். சுந்தரம் வந்து பேசினபோது சொன்னாங்க இல்லையா, உங்களுக்கு பிடிச்ச ஜாப் அதுலயே கிடைச்சதுன்னா that is the best thing you can ask for, right? ஸோ எந்த மாதிரி உங்களுக்கு இன்ட்ரெஸ்ட் இருக்கு, எந்த மாதிரி ஒரு இன்ட்ரெஸ்ட் இருக்கு, ரொம்ப டெக்னிக்கல், ரொம்ப மேத் எனக்கு ரொம்ப பிடிக்கும், மேத்ல கால்குலேஷன் ரொம்ப பிடிக்கும், அந்த மாதிரி ஜாப் போனீங்கன்னா யூ வில் எக்ஸல். இல்ல எனக்கு அதெல்லாம் பிடிக்காது, எனக்கு மேனேஜிங் பீப்புள், மேனேஜ்மெண்ட், ஆர்கனைசிங் அது மாதிரி பிடிக்கும்னா அந்த மாதிரி நீங்க சூஸ் பண்ணி போனீங்கன்னா யூ வில் எக்ஸல் இன் தட். ஸோ அண்டர்ஸ்டாண்ட் யுவர் what you are best at it and then try to explore the best fitting career opportunities around that areas. And career decision, make a decision, stick to it. யாரோ ஒருத்தங்க பேசும்போது கூட சொல்லியிருந்தாங்க 3 years, I mean ஒரு ரூல் ஆஃப் தம் வந்து ஒரு stick to a job for 3 years. Try to understand, try to become deeper in the knowledge and then try to switch on, right? நீங்க சொந்த பிசினஸ் பண்றா, உங்க அப்பாவோட பிசினஸ் டேக் ஓவர் பண்றதா இருந்தா கூட ஒரு 3 வருஷம் வந்து ஒரு வேலையாள் மாதிரி வேலை பார்த்தீங்கன்னா தான் you can understand what's going on. You can never become boss on from day one without understanding what is the fundamentals, without folding your sleeves up, right? So you need to dirty your hands, understand, learn, and then you can become a good in your career. So career decision is very important and stick to it. Don't keep switching around. And skill mapping, of course, skill mapping is the as I said, your weakness என்னவோ இல்ல உங்க strength என்னவோ அதுக்கு தகுந்த மாதிரி பில்ட் பண்றது, பிளஸ் உங்களுக்கு என்ன தேவையோ அதுக்கு தகுந்த மாதிரி. ஸோ ஸ்கில் மேப்பிங் இஸ் இம்பார்ட்டன்ட் அண்ட் இட்ஸ் அ கண்டினியூஸ் இம்ப்ரூவ்மெண்ட். நீங்க வந்து இன்னைக்கு இன்ஜினியரிங் படிச்ச என்னோட படிப்பு முடிஞ்சிருச்சு கண்டிப்பா கிடையாது. எனக்கு வயசு 51 ஆயிருச்சு, 25 வருஷமா ஒர்க் பண்ணிட்டு இருக்கேன். இன்னும் ஐம் லேர்னிங், இன்னும் வந்து ட்ரைனிங் இருக்கு, இன்னும் வந்து இது இருக்கு. வி நீட் டு கண்டினியூஸ்லி ரெஃப்ரெஷ். ஏன்னா ஐ நீட் டு கம்பீட் வித் அ கை ஹூ இஸ் கமிங் அட் 25 years old and he is able to do the job faster than me. I want to be able to compete. அதுதான் என்னோட thought process. So அதனால it's a continuous learning. Skill mapping and continuous learning is much important, very important for any career, not only for semiconductor career. So this is about the career planning fundamentals, right? I just want to give you a simple thought on job versus career. நம்ம எல்லாருமே வந்து இன்க்ளூடிங் மை செல்ஃப், ஃபர்ஸ்ட் நம்ம எடுக்கிறது வந்து ஜாப். அதாவது ஷார்ட் டேர்ம், கண்டிப்பா ஒரு வேலை வேணும். ஏன்னா எல்லாம் பக்கத்து வீட்டுல சொந்தக்காரன், வெளியில போறவன் வரவன் எல்லாருமே கேட்கறான், என்னப்பா இன்ஜினியரிங் முடிச்சுட்டா வேலை கிடைக்கலையான்னு கேட்பாங்க. ஸோ அந்த ஜாப்ங்கிறது வேற, கெரியருங்கிறது வேற. அந்த ஜாப் வந்து ஃபர்ஸ்ட் ஒரு ஷார்ட் டேர்ம், யூ நீட் அ குவிக் இது, இன்ஜினியரிங் முடிச்சதுக்கு அப்புறம் ஒரு வேலையை எடுத்துட்டு அதுல கத்துக்கிட்டு அந்த மாதிரி. ஆனா கெரியர் அப்படி கிடையாது, இட்ஸ் லாங் டேர்ம். உங்களுக்கு பிடிச்சதை யூ ஹேவ் த சாய்ஸ். You have the choice. If you like it, then you continue to build on that career. So first கிடைக்கிறதே தான் கடைசி வரைக்கும் வேற, வழி இல்லாம இருக்கிறது வேற. அதை நான் சொல்ல வரல. பட் ஆனா ஜென்ரலா சொல்ல வர்றது வந்து ஜாப் வர்சஸ் கெரியர், இதை புரிஞ்சுக்கோங்க. ஃபர்ஸ்ட் கிடைக்கிறதே வந்து உங்களுக்கு பிடிச்சது கிடைக்கலன்னா அதை பிடிச்சிக்கிற மாதிரி பண்றது ஒரு வழி. பட் ஆனா அது நம்ம பிடிச்சது கிடைக்கிற வரைக்கும் தேடிக்கிட்டே இருக்கிறது இன்னொரு வழி. So you have to know what you want so that you can do well whatever you do. So just take note of that. and setting smart goals, right? இதெல்லாம் வந்துட்டு கரியர்ல மிட் கரியர்ல தான் வந்து ரொம்ப பேசுவோம். பட் ஆனா நான் என்ன சொல்றேன்னாக்கா, as a student, ஃபைனல் இயர் ஸ்டூடெண்டா இப்பவே நீங்க வந்து கோல்ஸ், உங்களோட கோல்ஸ் என்னங்கிறத வந்து ஸ்மார்ட்டா திங்க் பண்ண ஆரம்பிச்சீங்கன்னா you can win the world by leaps and bounds. That is my humble request. So smart goal, be specific, give yourself a timeline, measurable timeline. எனக்கு இந்த இதுக்குள்ள இந்த மாதிரி ஒரு வேலை எனக்கு கிடைச்சாகணும், அதுக்கு நான் இதை படிச்சாகணும், இதை படிச்சு இத்தனை மார்க் வாங்கி ஆகணும், இந்த மாதிரி ஸ்பெசிஃபிக்கா மெஷரபிள் கோல். அந்த கோலை அச்சீவ் பண்றதுக்கு உங்களால நீங்க வந்து முயற்சி பண்ணிக்கிட்டே இருக்கணும். அந்த கோல் வந்து அந்த கோலுக்கு நீங்க உண்மையா இருக்கணும். நீங்க கோலை மாத்திட்டே இருக்கக்கூடாது. ஒரு கோல் பண்ணி அதை உண்மையா வச்சு அதை அச்சீவ் பண்ணி அடுத்த கோல் போகணும். நான் ஐம் ஆடிங் ஈவன் ஸ்மார்ட்டர் நான் சொல்றேன். ஏன்னாக்க ஆல் கீப் கண்டினியூஸ்லி இவாலுவேட்டிங் அண்ட் ரிவ்யூவிங் த கோல். ஏன்னா கோல் என்விரான்மெண்ட்னால சேஞ்ச் ஆகலாம். இப்போ இந்த கோவிட்னால நிறைய போட்ட திட்டங்கள் எல்லாமே மாறி போச்சு இல்லையா? போன வருஷம் நிறைய பேரோட திட்டங்கள் எல்லாமே வாழ்க்கையை உலகமே புரண்டு போட்டுருச்சு இல்லையா? அப்போ வந்து யூ கேனாட் ஸ்டிக் ஆன் டு த ஓல்ட் கோல். ஸோ யூ ஹேவ் டு ரிவ்யூ, evaluate, keep changing it, keep making it more realistic and more achievable, and keep achieving those goals, right? So always think about what is your goal, what is your goal in life, what is your goal for this 1 year. Finally இப்ப 2021 நான் ஜூன்ல முடிக்கிறேன், 2022 ஜூனுக்குள்ள என்ன பண்ணணும், அந்த மாதிரி ஸ்பெசிஃபிக்கா start thinking. That will help you guide your way, find your path. அதுக்கு வந்து முக்கியமானது வந்து டைம் மேனேஜ்மெண்ட். I will always emphasize this as a mentor to my young mentees. I'm telling you again, I'm telling the same thing to my kids as well. Time management, இதை நீங்க வந்து எவ்வளோ சீக்கிரம் பண்ண ஆரம்பிக்கிறீங்களோ, எவ்வளோ சீக்கிரம் கத்துக்கிறீங்களோ, அவ்வளோ நல்லது. ஸோ either run the day or the day runs youங்கிறது வந்து ஒரு கோட்டு. ஸோ I'm just telling you, time management is very important. ஒரு விஷயம் செய்யணும்னா அதை செய்யறத, அந்த டைமுக்கு செய்யறத, ப்ரொக்ராஸ்டினேட் பண்ணாம செய்யறது வந்து very very important. So please take note. These are all kind of soft skills that will help you in finding your career, dream career. So let me end up with a quote from Eleanor Roosevelt. இதுதான் அப்துல் கலாம் சொல்லியிருக்காரு. பட் ஆனால் the future belongs to those who believe in the beauty of their dreams. உங்க ஒரு கனவு ஒன்று நீங்க நினைச்சிருந்தீங்க, உங்களோட ஆசை ஒன்று இருந்ததுன்னா அந்த ஆசையோட அழகை வந்து எப்பவுமே நினைச்சிட்டே இருங்க. அது உண்மையா நினைங்க, உண்மையா தேடுங்க, கண்டிப்பா உங்களுக்கு கிடைக்கும். இதேதான் அப்துல் கலாம் சொல்லியிருக்காரு. இன்னொன்னு நான் சொல்லுவேன், இன்டெகிரிட்டி. தீதும் நன்றும் பிறர் தர வாரா. யூ ஆர் ரெஸ்பான்சிபிள் ஃபார் யுவர் ஓன் டூ குட் ஆர் பேட். உங்க கையில தான் இருக்கு, வாழ்க்கை உங்க கையில தான் இருக்கு. ஸோ இதையும் மறந்துடாதீங்க. Good luck in all your future endeavors. And this is my LinkedIn contact. For any help, anybody who needs can always reach out to me via LinkedIn. I'll do my best kind of giving my guidance and whatever I can do. And thank you for the opportunity again, AUAA, Mahendra and Damodara.
Thank you for the inspiring speech, sir. Sir, Mr. Raghavan, sir, I have a question for you.
Sure.
Do semiconductor companies offer jobs only to students with electronic background, or even students from other branches like chemical, mechanical are also preferred?
Yeah, I mean all branches. நான் என்னோட இதுல நான் சொன்ன மாதிரி கெமிக்கல், ஏன்னா செமிகண்டக்டர் இண்டஸ்ட்ரியில வந்து மேனுஃபேக்சரிங் மட்டும் கிடையாது இல்லையா, ஃபெயிலியர் அனாலிசிஸ் இருக்கு, மெட்டீரியல்ஸ் அனாலிசிஸ் இருக்கு. ஸோ அதனால என்விரான்மெண்டல் இருக்கு, ஃபெசிலிட்டிஸ், நான் சொன்ன மாதிரி ஃபெசிலிட்டிஸ் இருக்கு. ஸோ ஆல் பிரான்ச்சஸ் ஆர் ஈக்குவலி நீடட் டு ரன் அ செமிகண்டக்டர் கம்பெனி. யா, எலக்ட்ரானிக்ஸ் வந்து பேசிக் ஃபண்டமெண்டல் தெரிஞ்சதுன்னா, பிகாஸ் தட் இஸ் த கோர் ஆஃப் த பிஸ்னஸ். எலக்ட்ரானிக்ஸ், ஒரு டிரான்சிஸ்டர் எப்படி ஒர்க் பண்ணுது, ஒரு என்பிஎன் டிரான்சிஸ்டர், அது அந்த கோர் தெரிஞ்சதுன்னா யூ வில் பி அ பிகர் அட்வான்டேஜ். அது தெரியாம வந்து ஒண்ணுமே அதை பத்தி ஒண்ணுமே தெரியாம வேலை பார்க்கறதுங்கிறது வந்து இட் வில் பி டஃபர் இன் தட் இண்டஸ்ட்ரி, ரைட்? ஸோ யூ நீட் டு, தட் இஸ் அ கோர். பட் ஆனா எல்லா பிரான்ச்சுக்குமே வந்து ஆப்பர்ச்சுனிட்டிஸ் கண்டிப்பா.
So Venkat sir, I have a question for you. Is master degree a must to enter into the semiconductor industry, and we pursue masters after joining in one of the companies?
So I would say most of the design related jobs would require the graduate degree. It's because we don't go, as like someone else pointed out, even in E&I, EC, everywhere, we do 1 or 2 courses on the logic design. And I'm not sure if the syllabus has changed recently, but Verilog, knowing Verilog language to code, how to mimic a hardware implementation, is like you need to be thorough in it. And then there are a lot of other things that go with it. So that will make it easier, but there may be a smaller set of opportunities available. Like it doesn't need like a graduate degree. And as Shiva also pointed out, most of there is a regular channel of like internship and co-op that happens through the graduate school. So this increases your probability of like finding a good job if you want to do design and related activity. Okay, so.
So Kumar sir, I have a question for you, sir. What is your advice to average students, especially from rural areas, on how to grow up in career?
I think there are a couple of real good suggestions in the motivation talks that's been given by everyone. Listen to Chockalingham's talk. Like really, he has listed down how to be successful, right? I think it doesn't matter whether you are from a rural background or something, right? So as long as you have a burning desire, he calls out, he lists out exact sequence. If you follow those, it'll be there. Some of them that I followed that matches with him is burning desire, right? And as long as you, and also Raghavan also listed down a sequence, right? So as long as you have a desire to succeed and you have selected a career path and domain and focus on it. And Venkat also talked about the same thing, the depth. Once you've fixed a particular domain, you really have to go in deeper. Breadth is good to understand the tangible things that are associated with it so that you have a holistic view, but you have to have a depth in one area. Like you have to focus, spend time on it. And Raghavan also touched upon it briefly, telling that you should spend at least 3 years in a company, like to understand the company better and the role that you are playing, how you are going to impact the business. So all this is important. Like as long as you have self-confidence, you have a burning desire, I think it doesn't matter whether you're coming from a rural background or something. So I think you should just throw away those inhibitions that you're coming up from a rural background. Like you are already in a reputed university. You are studying in a reputed university. You are coming out from a reputed university. So I think you are in a better advantage. It doesn't matter you are from a rural background.
Sir, all of you have stayed in 1 or 2 companies throughout your career. Is it good in today's scenario? When should we look up for a change in the career?
Was that question to me, Bhuneshwar?
When should we look for the change in the career? All of you have working toward 1 or 2 companies throughout the career. Is it good today's scenario? When should we look for a change in the career?
Yeah, let me take up that because I'm the one that never changed the company for more than at least Siva, I think 2 companies, and Venkat is also, Venkat and me never changed the company, right? I think change, you don't have to force a change unnecessarily. That's my view. If you have a kind of if you have a comfortable comfort zone, and if it is no challenges to look forward, that's when you think about changing, right? But if you keep on within the company, because these semiconductor companies are really huge, you have like multiple areas where you can explore within the company. So when in my career page I had, right, I just went on from one area of focus into other area of focus every 3-4 years. And then I went into automotive, then I went into fab management, and then went into manufacturing quality. Then I moved to supplier, then customer quality. So every area you then you start from the beginning. You learn, overcome the challenges. You become an expert there. Then you start moving around, right? So if you have the opportunities within the same company, then you don't even worry about switching the company. But if you when you feel stagnant, or when you feel that you're too comfort and there is nothing much to look forward, that's when you have to look for a change, I believe. That's my view. Maybe Venkat can add on his thoughts.
Good point. So even though I worked, Intel is the only company I worked for 25 plus years, I moved around different product lines. So I started with Pentium. I was a circuit designer there, and then I joined like a server design, and I spent like 3 years doing design automation. When I say design, of implementing design, and then I moved to networking, network processor design. So when I moved, I wanted to work on a smaller team, so I can take on more load. So one thing in the technology, this is my personal interest, and what I learned is this: take on big challenges. Okay, so that's where you will stretch yourself. You will find out all your capabilities are. You'll be really surprised how much you can accomplish. Okay, it's just not only in this. This is true in in general for life, right? I'll give you a simple example outside. 6 years back, I wanted to get into running. I started running, and then I ended up running 2 marathons back to back. Okay, for a person who has never run regularly, until I did that, within a year, less than a year, I ran 2 marathons. Think about it, right? So that is 42 kilometers nonstop under 5, around 5 hours. So you will realize your potential. So when you go into that domain, try to learn. It is all about how much life experience you are gathering. It is all when I joined the network processor, I learned everything about networking. How, when you click on a web button, how does it go and fetch data? So I wanted to understand that. So it's not that related directly to my job, but that gave me depth of knowledge, and then the adjacent. So that is one thing. And then the other factor that you may want to use, an indicator when you want to switch, is if you're getting bored with what you're doing, then you may want to start thinking hey, that means you're not being challenged. Complacency is settling in. So that could be another indicator. Okay, so.
Yeah, I can add a couple more there, because I've changed 4 jobs, right? Though predominantly I've been in Intel and AMD, but I have made switches, right? So basically, the first switch, right, was mainly because I was not purely in software, right? I was doing something. My passion has been on that, so I was doing something different. So I was looking for an opportunity, though I was working on compilers for PLCs, but my regular job, if you see, was to go on trips to in North India throughout to see any failures in Fanuc, Siemens, PLCs and everything, and find out the issues. And along with it, I was creating this software that I was talking about. But my passion was towards developing softwares and solutions on softwares, right? So the first opportunity that knocked my door to create a full-fledged software for a software company, I took it over, right? Moving to Chenab Information Systems to do the Swissair financial software, right? Then, as Raghavan said, right, though it is not a switch, he has looked at multiple aspects within the small company. Actually, it's a switch, right? Within the same company, within Global Foundries, he has looked at multiple aspects, right? So certainly he has gotten better at what he was doing for that particular amount of period. Might be spent in each of them a couple of years. And same with me. That's why I'm correlating it, like a couple of years you have spent, you have mastered that. Other adjacent things are something that you want to explore So there is opportunity within the same organization. It's equivalent to a switch. Basically, you are trying to get into a different aspect of the problem, right? So the only time that you would move is when it is opportunistically aligning to your what you want to do. Second is you want to really grow and improve your breadth for the holistic solution. Early parts of the career is breadth. You just increase your breadth, and later part of your career, it's just you found out a domain, you don't deep dwell into the domain. Like my initial career was so much diverse, like writing software in the application level, databases, and so once I found the domain, manageability is my domain, right? Then I stuck on to the domain. Within that domain, what else I can do? Because this semiconductor industry or any industry as such for nowadays changes very drastically day by day. So you have to keep up to the trend that is going on in the industry. So yeah, that's what I would add.
So recently we have heard the news that many people working in the Samsung are diagnosed cancer. What is your views on it? Semiconductor sensor producing as cancer.
Sorry, what is it? Can you repeat? Many people working in Samsung?
Samsung diagnosed cancer. It's all because of, all channels are saying it's all because of the sensor manufacturing unit. What is your views on it?
If I understand, Raghava, I think the question is related to cancer, you said, right? Does it help?
Health sensor manufacturing unit producing cancer.
We definitely, I mean, semiconductor industry uses definitely chemicals that are very, very toxic chemicals, right? So we have systems, we have we use arsenic a lot. Arsenic chemical engineering students maybe தெரியும். That's one of the very fatal chemical. இத்தனோண்டு ஒரு துளி எடுத்து நீங்க நாக்குல போட்டீங்கன்னா it will be very fatal. Arsenic அந்த மாதிரி ஒரு விஷயம். அது வந்து they use it in our implant module சொல்லுவோம். We use it, and அதுல வேலை பார்க்கறவங்களுக்கு வந்து they have like safety and medical tests and regular இதெல்லாம் requirements இருக்கு. அந்த மாதிரி the safety systems have been built over the years, like to make it more safe for the human, right? And we do have like gas and toxic gas alarms and everything that has been set up in the manufacturing line to ensure that we don't miss anything and makes a problem to the human. I mean, foreign countries பொறுத்த வரைக்கும் இருக்கிற மேனுஃபேக்சரிங் யூனிட்ல அந்த மாதிரி நான் எதுவும் இது வரைக்கும் பெருசா கேள்விப்பட்ட மாதிரி எனக்கு தெரியல. மேபி I'm not aware of what is going on in India. Samsung, is it in India? Samsung, the cancer is it?
North Korea, South Korea. Channels are telling. Okay.
Yeah, but I don't think I would like to relate directly a semiconductor industry working to cancer. I mean, மத்த எல்லா இடத்துலயும் தான் கேன்சர் வருது. So, but definitely, I mean, the awareness நான் சொல்றேன், we use lot of toxic chemicals. Lots and lots. I mean, we are getting exposed. அதனால தான் வந்து அந்த fab manufacturing இது வந்து they will call it as clean room. ஆபரேஷன் தியேட்டரை விட கிளீனா இருக்கும். இப்போ நீங்க ஒரு ஹார்ட் சர்ஜரி பண்றாங்களே ஆபரேஷன் தியேட்டர், ஓப்பன் ஹார்ட் சர்ஜரி பண்ற ஆபரேஷன் தியேட்டரை விட கிளீன்லினஸ் இன்னும் ஜாஸ்தி மெயின்டைன் பண்ணும் கிளீன் ரூம்ல. ஏன்னா வேஃபர் வந்து இல்லைன்னா இந்த ஐசி சிப் வந்து வேலை செய்யாது நம்ம பார்ட்டிகல்ஸ் விழுந்துருச்சுன்னா. ஸோ அதனால அந்த மாதிரி ஒரு கிளீனான ஒரு என்வரான்மெண்ட்ல தான் அதை வந்து பண்றோம். அண்ட் தெர் இஸ் லாட் ஆஃப் மெத்தட்ஸ் அண்ட் கண்ட்ரோல்ஸ் இன் பிளேஸ் டு என்ஷூர் human safety is taken care.
So what's the difference between Intel processor and AMD processor?
You want me to answer as a stock market guy? இப்போ வந்து AMD is darling stock. இல்லைன்னா இன்னொன்னு சொல்லணும்னாக்கா AMD வந்து cheaper than Intel. அவ்வளவுதான் எனக்கு தெரியும். Yeah, so I was just making it light. Yeah.
No, that's fine, Raghava. There is nothing that I want to add there too much. It's both are x86 based processors. Just AMD has GPUs as well. Intel is also working towards it. Intel has CPUs, GPUs as well. GPUs. Intel is working on GPUs, but AMD already has GPUs. And AMD also has a APU line of products, which is a combination of CPUs and GPUs. It is called as APU. These are the major differences, but process technology-wise, the segment in which it goes, all that might be specific and different, and the penetration they have, the market shares they have, all that are different. But both are x86-based processes. You want to add, Venkat?
Yeah. So yeah, I agree with what you just said. Both of them use the same architecture, the x86, because it's cross-licensed between AMD and Intel. I believe the question is from simple the personal computer or laptop point of view. So both of them make, I would say, equally good quality processor that would serve the needs for what you're trying to do, and whatever works works for your budget and the specs, what you need. You can go with either one, and I don't think you're going to be wrong.
Next question. Can Intel and AMD, can we able to attend the internship offers by Intel and AMD?
Yeah, so as I said, most of, so I'm based in US, Santa Clara. So I don't do any hiring in India directly. And that is managed by the local HR department. But what I know by interacting with the teams there in Bangalore is most of our hires happen for graduate degree programs. I'll let Shiva add to it,
yes, we do have internships and co-op opportunities in AMD, but as of today, in India itself, I'm talking about it is for MTech students, right? Master's students. That is where we go with to start. We are trying to reach out to Tier 2 colleges as well for masters. At present, it is Tier 1 colleges that we approach to. That is a reality today. But the important point is masters is something that is the entry level that we consider even for co-ops opportunities. That's where we are today.
Sir, do a fresher need to undergo any private training for joining an R&D?
I have not gone through any training before joining AMD or Intel. It was, I joined in between. I think Venkat joined immediately after his college, I think. As from a specialization point of view, he made it very clear, right, just a bachelor's is not sufficient. You should have some specialization towards the semiconductor industry. Related items, but Raghavan also talked about all the engineering areas in which you can enter a semiconductor. It's not if you're a master's or a PhD in only electronics or something that you can get an opportunity in semiconductor. It can be in other areas as well. Though if it is VLSI design or something, it is very evident that you will have an opportunity. But other branches also have an opportunity. But specialization is must, is what the consensus would be. I'll leave Raghavan and Venkat to add.
Yeah, another thing I would like to maybe tell you is okay, in India or a situation only, the competition is so high, right? You have so many engineering colleges and so many engineering graduates come out every year. And that's why the entry levels are getting tougher and tougher, right? Even to consider you as an applicant, I think they want a minimum master degree, right? How can you improve your chances with a bachelor degree? I think some of the things that you can consider, I would say, is research related stuff and projects. When you do the project, right, how you are connecting a project to your career that you want to achieve, right? So make sure your project kind of adds value to your degree, not just, not just going through the motion and getting the project report signed by the HOD and finishing the vivavos just for the examination point of view, right? That is one way to finish the project and get the degree. But if you truly spend time in that project, I think that will give you an edge when you get a chance for an interview, or when you get a chance for a job opportunity. Your project will help you to kind of propel your a little bit better compared to the competitors, right? If you do well in the project, maybe those are the things you can consider, how to improve your chances of success in. And of course, I think we have most of these major companies, we have these competitive exams. I think as even for consideration for jobs, right? All the big companies, all the public sector companies, all the big ones, I think they have these exams, and you have to do well. That is on top of your getting a good degree, good marks in your engineering. On top of that, you need to learn the technique of how to ace these competitive exams, right? I mean, that is a special training that you can only get in India. I think I'm telling you, it's very very needed and very important. And there is a lot of guidance provided from the university and also outside. If at all you're spending money on other than college degree, I think you should spend on those kind of things where you can add value to yourself. That'll be my 2 cents worth of advice on how to make yourself more competitive.
Sir, one final question. What skills do we need to have today to join one of the semiconductor companies in hardware as well as software?
Can you repeat that question? There was some noise. Did you get it, Raghav or Venkat? What was the question?
No. First part was I heard an echo. So if you could, please, Paul, if you could repeat that question, it will be helpful.
Paul, can you repeat it?
Can you repeat the question, Paul?
He's on mute. Paul, mute.
Okay, sir. What skills do we need to have today to join one of the semiconductor companies in hardware as well as software?
Okay, I'll take it from the software side. What skills do you need? Obviously, I talked about the entire stack, right? I just threw a picture there and talked about the entire stack, right from the firmware, right from the BIOS applications, everything, even until the machine learning space, right? There is nothing in particular. Obviously, it's C++ in the lower level assembly language. C are good skills to have for the code that you write in the firmware level. And as you move in the application side, because of the trend that is happening towards machine learning, any frameworks on the machine learning like Torch, all those framework related skills is good. But predominantly it is C is what I would say. But though Java is related to the performance, because at the end of the day, in the semiconductor industry from software side, we want to provide performance, right? Performance of the SoCs is tested, right? There is a separate performance lab where all the programming languages and compilers are fine-tuned towards the SoC, right? Because it has its own instruction set and everything. There are specific ingredients added, secret sauces added by Intel and AMD appropriately to improve and show the performance is better in their own cores, right? So a general knowledge in C and Java is what I would say is needed, apart from a higher level applications like machine learning and so on and so forth. Go ahead, Venkat.
From manufacturing, yeah, Venkat, you go. Yeah.
Oh, okay. So from hardware design point of view, you need to do like digital logic design, right? So digital logic design, typically there'll be like different levels of courses. I'm talking about the graduate level programs here, at least 2 levels of courses for a digital design. And then computer architecture would be a required course. And then circuit design would be nice to have. And then within there, so that gives you like, kind of a broad understanding of how it is done. And then you could do something on like the Verilog, which is the key language that is used for like defining the hardware implementation. And then at least one that is like a kind of a lab emphasizing. So to give an example, basically one of the courses that I did, they gave me a bunch of chips. And then we had to assemble a simple board computer and program it, and then like, do basic arithmetics, right? Like, do some addition, division, and so they give you some specifications. So that gives you like more exposure. So that is on the front end of the design implementation. And then the back end would be like synthesis. Once you write something in an RTL, simple adder, let's say, you want to synthesize, there are tools available, academic tools or commercial tools. Typically, all the schools will have licenses for commercial tools at a reduced or like a free license. And you can synthesize that and then like simulate it and show that like, what you implemented at RTL level, you can actually take it for manufacturing, pretty close to it. And it meets the performance goals, like in terms of timing. What I mean by timing is when you say like a chip is running at like 2 gigahertz or 1 gigahertz or whatever it is, something like equivalent to that. So this gives you a very broad set of like all the knowledge, skills that you would need to do any of the design side of things. Okay, and with this, once you get a co-op or internship, then as I said, you may go into. There are people that I know spend 20 years in just doing clock design or power design. Like we are talking about billion devices, like more than billion transistors in a chip that goes into a laptop. So you want robust, like, power delivery, similar to like, what is there happening in the real world power delivery system for like, power for our house and home, the office and the factories. Same kind of a thing is applicable even at a chip level. So you could just choose a career in just power design, clock design, memory design, different kinds of memories, or like just a validation and or like test or synthesis and so on and so forth. But to start with, I just gave you like at a high level what you would need skill set and to get it going.
Yeah, I mean, they've touched more detail, but there's one specific skill, right? Fundamentally, I think your electronics subject, you should be strong. I mean, the engineering, you will have an elective if you're in a different field, but if you're an electronics and instrumentation engineer or a communication engineer, I think you have basic electronic subject. And then the transistor, the fundamental physics, the device physics of the transistor, the fundamentals, you have to be strong. Because the first, whichever company you're getting in, right, the first few testing methodologies will be around those fundamental testing. How good is your understanding about a transistor? What is the device? What is the IV curve? That kind of, I'm talking about a basic stuff you will be tested. If you do well in that, that's when you clear that first step and then get into the second stage, right? That's where your soft skills all come into play. Group discussion. I don't know how many campus interviews you might have attended, the final year students. Group discussion is one of the major, because just to assess your communication ability, right? How well you can articulate a point, how well you can drive home a point, that kind of assessment is what group discussion is about. So the first fundamental skills, if you ask, is your technical depth in the knowledge. And once you get into an interview stage, I think you need to really prepare well, like much better than how you prepare for an exam. That's when you can do well in the interview, right? So, I mean, there is no one specific skill you can attribute and then you can get a job in semiconductor. It's like you have to be good in the subject. Then once you cross the first level, then the rest of the soft skills. So in my opinion, from my own experience, I was struggling in the soft skill, I would say, soft skill. And I got better at it. And then I knew how to navigate, even though I'm not very strong and technical, but with my strength in the soft skills, I was able to maneuver my way out in my career. So that's why knowing what is your strength and what is your weakness is very, very important. I hope.
Sir, and your thoughts about Annamalai University and how it has helped you in achieving what you are today, can we all share with your views?
சரியா கேட்கலம்மா, நீ உன்னோட மைக் சரியா கேட்கல.
Sir, what is your thoughts about Annamalai University and how it has helped you to and what you are today? Can you all share a few words?
Oh my God, Annamalai University is everything for us. Anna, as I said, நான் வந்து அண்ணாமலையில படிச்சுட்டு தான் சைப்ரஸ்ல போய் படித்தேன். அண்ணாமலையில படிச்சது வந்து we learned life there. That's what I mean. When we came to Annamalai, வீட்டில் 12வது வரைக்கும் வந்து they were taking care of so well. Everything is taken care. Everything is there for you. அந்த மாதிரி ஒரு சிச்சுவேஷன்ல இருந்துட்டு when we come to Annamalai University, we lived on our own. We managed our own. We learned life. And of course, friends, right? So friends, we got friendship that lasts for life until today. And so Annamalai University, maybe I should share this specifically, right? Immediately after graduation in Annamalai University in India, I was not able to crack through any job because as I told earlier, right, I was not in the top of the cream kind of a student. I was average, like 70% or something like that. And even some of the competitive exam, the minimum was 75. I couldn't even qualify to appear for that competitive exam, right? That's how used to be the situation. And I didn't get a good career or good start in SPIC because those days, if you get a job in SPIC or SIV and a few companies, Ashok Leyland, and there are a few companies, right? People will get into the job and your career and life is settled. But I was not one of them. I didn't get any of that. So, after you come out, and then you start applying for jobs, then you realize really the competition in the world, right? Because people are competing from PHG Tech, GCT, CIT, Anna University, everywhere, right? Among those competition, Annamalai University is very, very tough to beat that competition. But to the contrary, 4 years later, I landed in Singapore looking for a job after my MBA. You know, my MBA didn't help me much in that job hunt, but Annamalai University did. Annamalai University had such a great reputation in Singapore because of the alumnus from the old Annamalai University, from civil, chemical, mechanical. They were all in big positions in Singapore and professional engineering boards kind of thing, and NUS faculty, NTU faculty. So Annamalai University had a synonymous name and reputation in Singapore, which was really, really surprising. And they used to, the immigration officer, asked me straight away, is it the are you guys, is Anna University short form of Annamalai University? Because I also see degrees coming, people coming with a degree with Anna University and yours is Annamalai. Is it the short form for Annamalai? Because they thought everything is under Annamalai in Tamil Nadu. That's how the reputation was. So Annamalai University is, for me, is everything. I don't know what else to say. Yeah, maybe Siva, you can add on.
Yeah, from my perspective, I think we don't realize it like what it has provided. There were umpteen number of colleges, right? But the kind of facilities and it was Annamalai University was a vast, big college, like it was a university, right? So doing engineering there, where the library was so huge and the labs was. Literally, it gave hands-on experience. As I told, my first job was a startup. And to even think about trying to build something on my own, all that confidence was because of the microprocessor lab infrastructure that we had. We have done hands-on. And the project that I did was something related to it. The opportunity that the infrastructure gave, that was given to us in late 1980s, was huge. I do not think I would have got that in any other university in Tamil Nadu at that time frame, right? So might be Anna University might have had it, but none of the other colleges might have had that big an infrastructure. Apart from that, everyone's college life is adds different, because you're entering out of your family. It gives insights into how to face social life and everything. That will be there in any college if you have attended, and that too if you're in a hostel. If you're not a day scholar, you would have got that opportunity. But Annamalai University, for me, I see it as the infrastructure that was provided in that time frame. It had a very good infrastructure, the labs and libraries and the huge, vast infrastructure that it has certainly added value, I think. Go ahead, Venkat.
Yeah, so I want to reiterate the point. So one thing to keep in mind is Annamalai Engineering specifically has excellent lab facilities. Okay, doubly I know the electrical machines lab, and then I know mechanical, because we had to do 1 or 2 courses in mechanical labs as well. The IC lab there. And then similarly civil, the turbine labs and the workshops, and the chemical, we know everything about it. It has excellent, okay. And even today I remember how to do few of the things, how they, what I learned from the electrical labs, okay. So that is, if you want to learn, I was really good with doing things practically. So so I learned quite a bit there. But other than the technical side, so I got I was a good student. I could have been if I pushed myself, I could have been a great student. But then I would have missed out so much of fun, right? What's the point in it? Then life would have been boring. So I was always just trying to strike a balance between goodness on good side of my things, and then the naughty side of my things. Okay, and that worked out well. But the main takeaway that I want to summarize what others have said is, it taught me life, dealing with people, tough things in life, tough challenges, and how to deal with it. When I say the toughest one I faced is despite having 80+%, I didn't get a distinction because I was debarred for a semester, okay, for all the fun things that we did. So the point is, when you go through those kind of challenges, you can face anything. Later on, when I came over to US and then I was studying, it gave me such a good confidence about handling anything that I could. And also I was working part-time. I felt so good, okay? I didn't feel like taking support from my parent after the first year. So through summer, I worked and then earned my money to pay for the next semester. And then eventually I got a research assistantship and so on and so forth. But it is the life lessons that we learn, and then the ability to feel confident about facing any challenges. So be confident. You have all the life skills, in the 3 or 4 years that you have lived there. And you, as I said, to start with, go do something wonderful. You will be successful.
Thank you, sir, for all wonderful thoughts. We now request Dr. Dhanasekaran, sir, our placement officer, to give the concluding address.
Yes, sir. We had a long session. So the interaction session is bigger, more interesting and very useful to our students. Yes, sir. I thank Siva sir, Venkat sir, Raghavan sir. So nice of you for joining us. It's a very interesting input, sir. It's a different topic today, the semiconductor area. So getting speech on this topic is rare. It is our students are benefited. And in addition to that, the topic you have pointed out many points. So small, very fine points like facing interviews, starting from that, and what are the skills to develop. And one more point, studying higher studies. So PG is also now the requirement for some industries in your field, semiconductor field. Siva sir told. So now the joining PG students from our current batches are this season is not encouraging. So very few are taking PG studies. So I think the students can take these points. So in specialized area, they can do some PG studies and research, and they can go for industry. Definitely, they can start a career. This is one point. So thank you so much. US, you are joined from US this time, the odd time, and this shows your interest over us, the university, and our students. So it's really a inspirational and motivational speech from all you three speakers. So thank you so much, sir. So we need your support for the coming years. Also, I thank this time. I take this opportunity to thank Mahendra Kumar and the 92 batch for initiating this. And we had in the past 2 weeks, we are had lectures sessions from different topics, and it goes till this month end. I think now we are doing this for final years. I think if we start these kind of lectures for even when the students are entering into the college first year, so they can know, they understand the value of this, how our alumni are in like this. So definitely that will give the motivation to the students, freshers, so that we can plan, and when they join, immediately we can arrange these kind of lectures like induction, the training. So from alumni. So that will be, I think, more useful to our students. So they can make it, all the 4 years they can effectively, they can use this. They know the value of the course, and they can get the full thing of this. Thank you, sir. With this, I thank once again all of you for joining us.